You bring home a healthy houseplant, put it in a nice spot, and water it carefully. But within weeks, the leaves start turning yellow, drooping, and falling off. Under the surface, the root system is rotting away. This decay is driven by a specific physical phenomenon found at the bottom of every container, a saturated layer of soil called a perched water table. To prevent this, you can move away from traditional, dense garden soils and build a highly aerated, fast-draining substrate known as the 5-1-1 mix. To construct it, you need 4 things: a bag of pine bark fines, a compressed brick of coconut coir, some coarse perlite, and a large mixing bin. Mastering this specific substrate ratio allows you to maintain maximum aeration throughout the container, creating an environment where roots can thrive without the threat of saturation. Step 1 is preparing the base materials. We start with the coconut coir, which usually comes as a dry, compressed brick like this. Drop that hard brick into water and let it sit. Within a few minutes, it expands and softens into a fluffy, dirt-like texture. This light, moisture-retaining material takes the place of standard garden soil, which often presents significant physical challenges when trapped in a pot. Garden soil is very dense. It compacts tightly around the root system, restricting oxygen while harboring bacteria and fungi that can quickly infect a weakened plant. Next, take your pine bark fines and pour them through a sieve. You want to separate and throw away all the fine dust, keeping only the solid, chunky pieces of bark. Mixing this chunky bark with the hydrated coir ensures the mixture maintains its structure. Even when wet, oxygen can still reach the roots. Now we combine the ingredients using the 5-to-1-to-1 ratio. 5 parts consist of sifted pine bark, providing the rigid bulk of the aeration structure. The remaining 2 parts, 1 part coconut coir and 1 part coarse perlite, act as sponges, holding precise moisture between waterings. Dump these into a large tote and mix thoroughly by hand until the distribution is uniform. You can check your progress with a simple tactile test. A squeezed handful should feel light and chunky, falling apart easily without clumping when you release your grip. Establishing this specific, chunky physical structure is what allows the container to handle water differently than a standard potting mix. When repotting, start with an empty container that has clear drainage holes at the bottom. Under no circumstances should you put a layer of gravel or rocks at the pot's bottom. In a standard pot, gravity pulls water down, but capillary action pulls it up, creating a blue saturated zone at the base. Adding gravel doesn't remove this water, it displaces the saturated zone higher up, directly suffocating the main root zone. The proper technique is to skip the gravel and fill the pot entirely with 5-1-1 mix. Because the 5-1-1 mix is made of large particles, capillary action is extremely weak. This reduces the perched water table to near zero, solving the drainage problem through pure physics. To verify the mix is working, perform a heavy watering test over a sink or outdoors. Success is measured by speed. The water should flow through the substrate and stream out the bottom drainage holes almost instantaneously. While this porosity makes it nearly impossible to overwater, it also means the substrate will dry out much faster than traditional bagged soil. Adjust your behavior to match the mix, committing to more frequent watering sessions to keep the plant hydrated. Additionally, because processed bark lacks built-in nutrients, you must add a liquid fertilizer, like Foliage Pro, to your routine watering schedule. By taking active control over the plant's nutritional and watering needs, you effectively eliminate the environmental conditions that allow root rot to take hold. The final result is a vibrant houseplant sitting in its ideal structural environment. You've successfully built a professional, sustainable potting medium that uses physics to protect the root system. Now that your soil structure is dialed in, the next step is mastering your fertilizer ratios. Click the link on screen to see how to calculate your liquid nutrients for the best possible growth.